Welcome to another unit in business mathematics. This time I'm going to talk about using sums, how to work with sums, what sums actually are, or what the sum sign actually does. And I'm going to introduce three specific types of series or so-called sums. Well, let's start with the idea. What do we understand by the so-called sum sign? That's actually just a large sigma, where in the lower part I have the information first of what is the variable I'm working with. That's here the k, and the starting value, which is the m. The final value, that's up here on top of the sigma, that's the n. And I have here the ak, which I can imagine like some kind of function depending on the k. And this sum actually means that I'm inserting all numbers from m to n into this function. I'm always calculating the results and adding them up. So if I summarize what I just said again, the k is the index for the variable, the m is the starting value, the n is the final value, and the ak is my function. So just to give you an example on this, the easiest version would be something like this. This starts with a k of 1 and goes until a k of n. And my function here is just a function k. So I'm inserting 1. So write down 1 here, then plus, then I insert the next highest integer, which is 2. So write down 2, plus next highest integer, 3, insert 3, get this here, plus, and so forth, until I arrive at n. Here, I'm at my final value, the value up here, and I stop. Second example, maybe this makes it even a bit clearer. So here I go from 1 to 4. So I have to insert the values 1, 2, 3, and 4 into this function. So it's always the value squared. So I get 1 squared plus next highest value, 2 squared, plus next highest value, 3 squared, plus next highest value, 4 squared. Well, 4 already is the value up here, the final value. So here I stop. Then I can simply calculate the results. So 1 squared, 4, 9, 16, and add them all up, giving me my result here. Okay, so that's basically how sums or the sum sign works. And now there are some specific series I can actually use, some specific sums I can use. Let's first off the so-called arithmetic series, which looks like this. This is basically what we had before, summing up the first n numbers. To make this a bit easier, we have this type of formula here to make even this sum easier calculable, which is just the number of n times n plus 1 by 2. So if I would have 100 here, so basically the task of adding up the first 100 numbers, I would just go 100 times 100 plus 1 divided by 2. So in other words, it's just 100 by 2, so it's 50 times 101, which is just 5050. So it's relatively easy. That's the first one. This is one we're not going to use this much in the course of this lecture. In this lecture, the geometric or the infinite and finite geometric series are way more important, especially in the business mathematics part. And here we have something like this. So the important part first off, whereas the arithmetic series always starts at 1, the geometric series always has to start at 0. Then we have a certain factor here, which is q. And we have q to the power of this k. If we start at 0, it's basically q to the power of 0, so it always starts with 1. Then plus q to the power of 1 plus q to the power of 2, so forth, until q to the power of n. If we have this, we can simplify this by using this formula, which is just a very, well, let's call this sophisticated version of the third binomial form. So this is one way to make this a bit easier. And well, here we have a finite series. So we have a final value n. So this series stops at a certain point. If it does not stop, so if we have the infinite geometric series, we basically, as the only difference, have an infinity sign up here. So it continues indefinitely. In this regard, we have one requirement. This q, or rather the absolute of this q, needs to be smaller than 1. Only then can we actually calculate the result of this geometric series. If this is 1 or larger, minus 1 or smaller, we won't have a solution to this. If this is, when its absolute is smaller than 1, we can calculate this pretty easily. We can just go 1 divided by 1 minus this q, which is more or less, imagine we were to insert a very large value here for n, then this becomes more or less 0. We would have minus 1 divided by q minus 1. And that's actually the same thing as this one here. So they are closely related, with the only difference, here we have a finite value, here we have infinity. And those ones we're going to use, at least from a theoretical point of view, in some parts in the business mathematics context. Well, that's then already everything I wanted to mention with regard to those specific series. So I hope you enjoyed listening to it, and I say goodbye and see you next time.